Thank you.
Good way to go.
And thank you very much for your time today, folks. As Jim mentioned, my name's Eric Seineith. I'm a Chief Architect and Practice Director with AT&T Consulting, and I was told expressly this is a vendor-neutral presentation, so that is the last time that I will mention the term AT&T. What we're going to be talking about today is a really interesting intersection of Internet of Things technology and blockchain to solve some of the most pressing problems in supply chain operations. Some of the work that I and my team do with both private and public sector organizations is help them determine how best to utilize digital technology and specifically and technology in general to improve business operations. And as we'll talk about here in just a bit, supply chain or sustainment, as it's also termed in many of the public sector organizations, is a very ripe area for optimization. So we'll talk about that. I do have plenty of slides, and we're going to go into a fair amount of detail, but I'd much rather answer any questions that you may have rather than make sure we get through all of the slides. So if anything comes up, if you want to unpack anything, please just let me know and we'll talk about it. Okay? So in terms of blockchain, most people are familiar with blockchain, or at least they've heard of blockchain as it relates to things like Bitcoin and Ethereum. But realistically, Bitcoin is just one use case. Cryptocurrency is just one use case for blockchain, especially in enterprise organizations. The best way to think of blockchain, it's been defined as the next generation of the internet and something that's going to transform the world. Realistically, it's a database, but it's a very secure database and a distributed database as well, so it's very resilient in many operations. The best way that I think can explain what blockchain is, if you're not familiar, is again a database, or think of a spreadsheet, right? But with every row being a new record. The difference with blockchain is that every row is cryptographically hashed or linked with every previous row. In addition, blockchain is a distributed data store, so you can have the same copy of the data store on multiple different machines. You know, in the Bitcoin use case, it's actually installed on millions of PCs and servers around the world. You can actually download and install a full copy of the Bitcoin data store and even participate in some of the cryptographic mining operations. What that means, though, is that blockchain is an immutable data store. It is a write once, never change. So every record that you add to a blockchain data store is there for as long as that blockchain is in existence. And that's another kind of misconception that a lot of people have. There is no one blockchain. Just like there are millions or hundreds of millions of databases around the world and spreadsheets around the world, ultimately there are going to be multiple different blockchains that may be either public, like Bitcoin, it may be private, controlled by a specific enterprise or entity, or it may be consortium-based, meaning that multiple organizations own, quote-unquote, own and participate in the blockchain. The immutable nature of blockchain and the distributed nature of blockchain make it very, very good for keeping permanent records of information. And we'll talk about some of that information as it relates to supply chain in just a bit. Because it's immutable, because every record is linked to every prior record, and it's distributed, if someone were to want to make a change to a record, like to change a cash balance transaction, for example, not only would they have to change a specific record, they would then have to change every subsequent record that is linked back to that original record they want to change. More so, they would have to do it on every machine that has a copy of that data store. So it's a very good solution, not for all database or data store requirements, but if you need that immutable record, that immutable data store, and you need something that is very resilient in terms of being able to be distributed across multiple machines. We're seeing blockchain being used in a number of different ways across financial services, across manufacturing, and other industries. But what we're going to be talking about today is using blockchain and Internet of Things technologies to solve some of the challenges with most supply chain operations. And again, I'd welcome your feedback or any questions as we go forward. The reality is that blockchain is exploding. There's been almost 3,000 patents filed globally since 2016, almost $6 billion in venture capital funding, and that's just for last year, and this year's not quite over. So that's an awful lot of money that's going into developing this technology. In most industry surveys, a significant proportion of those surveyed believe that blockchain is going to have a tremendous impact on their industry. It may be disruptive, or it may be something that they can use to enhance their existing operations, and that's really what we're going to talk about today. A couple of other characteristics of blockchain as it relates to this is typically most blockchains are peer-to-peer, right? So Bitcoin, for example, doesn't require a bank or a central entity to act as a clearinghouse for transactions. In supply chain operations, most blockchain implementations will typically be either controlled by a single enterprise to integrate all of their upstream and downstream supply chain partners, or it could be implemented as part of a consortium. So providers like IBM, for example, is developing applications that make use of blockchain technologies to solve things like problems in the food industry in terms of resolving fraud and providing provenance, that type of thing. But they're opening it up to multiple different participants. So basically anyone in the food industry can participate and contribute data to this blockchain environment. So while it's produced by a single provider, in the case of IBM's Food Trust, it's being used across the entire food manufacturing and distribution and retailing industry as well. Blockchain has gone through some tremendous updates and changes since Satoshi Nakamoto first released the Bitcoin specification. And in reality, blockchain is not necessarily a brand new concept. Even though Bitcoin was really the first widespread commercial implementation of blockchain, the concept has been around for quite some time. What we saw initially was with the first generation of blockchain, it was just that. It was a basic ledger that you get to add records to. And that provided some good functionality. It addressed the double spend problem where, you didn't want an entity spending 2 units of value when they only had 1 to spend. But since then, we've seen tremendous activity in this space. So blockchain 2.0 added concepts such as smart contracts. So in addition to the ledger, with smart contracts, they're actually bits of code that encode the terms and conditions of a real-world contract, and they can be set to execute when certain conditions are met or after a certain time expires, for example. So smart contracts, let's say that in the supply chain space, a raw materials supplier wants to send materials to their distributor. So typically, in a lot of cases, there are specific points of sale where that payment is triggered. In a lot of cases today, that's a manual process. Some of the largest companies in the world still operate with email and fax machines and things like that to let them know, hey, we distributed this product, we sold this product, now you can take payment for that. By encoding those terms of that contract into a smart contract piece of code and attaching it to the blockchain, those things can be triggered to happen, like I said, when certain conditions are met. When a shipment clears customs, for example, maybe that's the point of sale. Or when a product is actually used, maybe that's the point of sale. The key characteristic, or the key requirement though, because blockchain is an immutable data store, you can't change a record once it's added, it's very, very critical that the data feeds, the data that you have feeding that blockchain, be very secure, very reliable, and very trustworthy. And so we're going to talk a bit more about how we're using IoT to address that as well. Some examples of the smart contracts and additional business logic an example is, for instance, the Ethereum blockchain. So Ethereum, it is a cryptocurrency, and that cryptocurrency is also used to power distributed applications as well. But again, companies and organizations are starting to build applications on top that leverage these blockchain capabilities. We're now really in the third generation of blockchain, and there are a couple of key considerations for that. One is cloud service provider support. So companies like IBM and Microsoft and Amazon have incorporated blockchain capabilities into their cloud offerings as well. We're also seeing more sophisticated middleware, so applications that sit between the user and the back-end data store that provide additional functionality that a blockchain, for example, may not provide. Just as in a traditional database environment, you may have a back-end database. You typically have some business logic application middleware, and then you have the front-end application that users access that information with. In addition, we're now starting to see blockchain being integrated with additional technologies like artificial intelligence and machine learning, Internet of Things, and that's really what we're going to focus on specifically here. But this evolution is increasing, and we anticipate that there's going to be a significant amount of innovation as part of this development. I mean, you saw the number of patents and the venture capital investment, very, very significant. So because blockchain is an immutable data store, it actually can facilitate transfers of value, monetary value, information value, basically anything of that can be represented digitally between parties. And where typically you may have required direct, trusted, contractual relationships between those entities, with blockchain, trust is actually an inherent part of the technology, right? Because we use public key cryptography, we use things like hashing to link these records together. In many cases now, it allows people to conduct commerce and business without having a trust relationship and without even knowing one another. Yes, sir?
But there's two parts to trust.
Mm-hmm.
Okay? Part A of the trust is that the transaction has occurred.
Right.
Totally agree with your argument there so far.
Right.
The problem that comes with this is also you're assuming that all parties are wanting to transact. Okay?
Mm-hmm.
And that the identity of those parties should be trusted. That's what you just said.
That is true. That is the case.
Okay. But that doesn't necessarily imply it's a matter of how I become part of that chain.
Yeah, that's absolutely the
how I
case.
get to participate in it as to whether I should be trusting the authenticity of the user
You're
or
absolutely.
the identity.
You're absolutely right. And there are multiple different types of blockchains. There are public permissionless blockchains like Bitcoin. Anybody can sign up for an ID and send Bitcoin value to anyone else on the Bitcoin network, right? In that case, we're using the public key PKI, the public key infrastructure, to establish not that I am the person that's assigned to this identity, but that this identity represented by a public key actually transacted with another person. In most financial services organizations, there's still what are called Know Your Customer, KYC regulations, right? So even though the Bitcoin blockchain is completely open and transparent, anyone can download a viewer to view any transaction on the Bitcoin blockchain. The challenge is anyone who downloads and reads it doesn't necessarily know that this Bitcoin address is Eric Sainith or anyone else. However, a lot of the cryptocurrency exchanges who are now transacting Bitcoin actually do maintain that mapping. So when you register with Coinbase, for example, and get a Bitcoin address, Coinbase is the one that actually maintains that mapping of personal identity to blockchain identity. But you're absolutely right. In that environment, we need to not only know that the transaction occurred, but we need to know that it actually did originate from someone with that ID. And I'll get to one more point, and then I'll be happy to take your question. The other area, and especially in the enterprise space, are what are known as permissioned blockchains. Right? And those blockchains can, again, be private. They can be owned by a single organization. They can be consortium-based. But in most cases, and especially in enterprise applications, there very much is a permission base that this role, this identity, is allowed to, for instance, update the blockchain. This role is allowed to read the blockchain only. Yes, sir, your point.
Yeah, I think that a lot of times the blockchain stuff, like with a lot of software as well, like the open source stuff, it gets identified with the openness of the concept. When you apply it to the supply chain, something that we work a lot with on is the question of how do I know that this component in my device was sourced not from Huawei, not from
Right.
China, from somewhere that I can trust, and how do I have that sign off? And and then when it goes from point A to point B, and you scan, say, the BIOS so that there's no malware between that transaction, it's good. So I think you think the who is being maybe two entities as well as just people, and then the what not being like that's what we buy, but things like they get inserted into the supply chain, especially in the digital realm.
Absolutely. Yeah, you're absolutely right. I mean, that's kind of what this slide begins to address. Some of the capabilities. Say again. Yeah, some of the capabilities that blockchain provides is identity, right? Not only knowing who did something, but what was done to a given thing. That's called provenance, right? So in a supply chain, to your point, it's very, very critical that we make sure that the component parts we're sourcing from a manufacturer are actually the component parts that we're receiving and putting into a net new device. But that requires that either I have that the manufacturer and I, as a distributor or assembler, participate in that blockchain, which will probably be private or permission, right? Or if they don't participate in it, we need some mechanism to onboard data into the blockchain data store that we're using. And as we'll talk about in just a moment, that's really where Internet of Things technologies come into play. Blockchain, in addition to helping to assure identity, because it's an immutable data store, we can verify that the transactions that happen on anything of value, parts or anything else, are immutably recorded, and we have transparency, again, based on permission, so that after the fact we can go back and audit and see what happened to each to that part or that component at each point in time. And really, it's about the interactions between supply chain participants. And we'll get a little bit more deeper into supply chain in just a moment. Just wanted to make sure that we had a bit of a technical grounding and foundation on blockchain, because it makes a lot more sense once we have that conversation. So as we all know, global supply chain is big. Right now, PricewaterhouseCoopers estimates that it's about a $9 trillion business globally. But what's more is by 2030, in 10 short years, they're expecting supply chain globally to triple to more than $27 trillion in total economic value. That is a huge number. But it makes sense with the rise in e-commerce and things like that. But that's causing a lot of challenges for supply chain managers and other operators. Number one is workforce shortage. Over the last year, we've worked with at least a few dozen major global companies who have very large supply chains. One of the biggest challenges they're having is finding people to fill the bill. There simply aren't enough people to fill the jobs that are going around. And that's at $9 or $10 trillion. Once it triples, that's going to be even more of a problem. Another challenge that supply chains face is that supply chains, on average, are some of the worst contributors to greenhouse gas emissions. Regardless of your views on global warming, the fact remains that we are producing a lot of not only CO2, but other pollutants as part of supply chain operations. Think of rail, think of shipping, think of over-the-road trucking, that type of thing. Security, maintaining the confidentiality, the integrity, and the availability of supply chain operations is a perennial problem for any enterprise. Government regulations, significant increase in regulatory impact. As a matter of fact, one that we're working on right now is with pharmaceutical companies. In 2013, Congress enacted the Drug Supply Chain Control Act, which basically means that the smallest unit of medication, whether it's a blister pack or a bottle or something like that, has to be serialized. And for controlled substances like narcotics, they have to maintain a consistent end-to-end chain of custody for those materials. And this is only going to be expected to only increase. So ultimately, since supply chain is becoming more pervasive, much larger, a lot more value, there's increasingly, to your point, it's very ripe for fraud. Food fraud, who knew that was such a thing, is a $40 billion a year global problem. And when you think about online grocery sales alone, in this year, in 2019, are expected to reach $100 billion. So it's a very target-rich environment. Where do you look for your wallet underneath the streetlight? Because that's where the money is, right? That type of thing. That concept applies here as well. When we think about supply chains, there are a couple of intrinsic operational issues with today's supply chains, no matter how well constructed or how well funded they may be. One is visibility. At some point in time in most supply chains, somebody loses visibility of either the location or the status or the condition of materials as they move through the supply chain. That causes a couple of major problems. One is the ability to forecast demand. We worked with a very large consumer packaged goods manufacturer just headquartered in Atlanta. And a few years ago, the amount of stuff they had to keep in their supply chain because their demand forecasting was, I think their demand forecasting accuracy was about 70%, and that was considered best in class, by the way. But that means 30% of the time they didn't have enough stuff coming in or going out to the right locations to satisfy demand. Because of that, they had to store more material in the supply chain. They call that days sales held in inventory. A few years ago, they had 50 days worth of stuff in inventory. A few years later, it was 70 days. Last year, it was 90 days. Now, for this company, every additional day's worth of stuff they have to store in their global supply chain is worth $200 million a year. So on one hand, it costs them, every additional day costs them $200 million a year. A corollary to that, though, is if they can reduce it by a day, that's a $200 million cost savings right to their bottom line. That is significant, right? So visibility is a major, major issue. The other issue is effective data sharing, right? Most people think, or many people think, that supply chains are just that linear, connected things, and in reality, they're not, right? It's really more of a hub and spoke model. Typically, people like raw material suppliers and third-party logistics and distributors and retailers have a hub and spoke relationship with a central party. They have trusted contractual relationships with a central party like a manufacturer. But in most cases, they don't have that same relationship with each other. So sharing information is a challenge, right? And because they're not able to share information effectively, on average, from the research that we've done, it takes one FTE between 24 and 72 hours to resolve a supply chain incident. So not only is there an immediate cost in that you have to pay that FTE to go resolve that supply chain incident, but if you're operating for a just-in-time manufacturing environment, for example, there may be tremendous downstream impacts like, idling a manufacturing facility, that type of thing. So sharing of data is a big problem. Most of the time, if let's say I have an Oracle supply chain management system and you have an SAP supply chain management system, I'm not going to directly connect and give my suppliers and distributors direct access to my supply chain management system. So data sharing and visibility, two major issues in supply chains. What we're proposing, and based on the work that we've done with a number of enterprises globally, is to use IoT and blockchain to resolve those two issues. Internet of Things, it's now, because of recent advances within the last 5 or so years, it's now commercially, meaning financially and technically feasible, to fully instrument supply chains end to end. You can instrument with always-on, always-connected sensors at the package level, at the pallet level, and even at the cargo container level. So it now makes sense and it costs less to provide that end-to-end instrumentation than the value of the contents, right? So again, that addresses the visibility issue. Blockchain is a very, very good solution to the data sharing issue, right? You've got, in the automotive industry, for example, there's a thing called the Automotive Network Exchange, ANX. Ford and Chrysler and General Motors have spent decades and at least hundreds of millions, if not billions of dollars, putting this automotive network exchange in place specifically to address the data sharing requirements with their parts suppliers. With IoT providing end-to-end visibility and instrumentation, and blockchain providing an immutable record and a more loosely coupled way to share supply chain information, we can accomplish most of what the big three auto manufacturers have done at a fraction of the cost and in at a much shorter time frame as well. Make sense? Any thoughts, comments, questions? Okay, we'll move on. So this is an example of a blockchain use case. Pretend that doesn't say AT&T and it just says IoT-enabled sensors, right? By instrumenting at the point of origin, the point of manufacture, or for raw materials, the point of collection, we can now establish where that material was, where those parts were, where they moved. But what's more, with IoT, we can also collect temperature and humidity and light exposure and tamper evidence, that type of thing. So we can collect not only location where this thing has been, but also what conditions it's been in. The consumer packaged goods manufacturer in Atlanta I mentioned, their project is perishable. If it doesn't get to where it needs to go within a certain amount of time, it's no good. If it sits out on a loading dock in 95-degree weather for a period of time, it's no good, right? So it's important not only to know the location, but also the status and condition of that information, or of that material. But by doing that at the point of origin, as it moves through testing and packaging, we can collect everything that happens to that. As it moves through shipping and third-party logistics, whether it's airborne or ocean-going or over the road, we know where it's been, we know what condition it's been maintained in, especially if it's part of what's called a controlled chain. A cold chain. Some materials like pharmaceuticals and food need to be maintained within a certain temperature range. With IoT sensors, we can now make sure that happens, and we can also send up a flag if something goes outside of those bands. So rather than waiting for a shipment to be delivered and discovering it's bad, the IoT sensor can automatically notify us when something has gone out of those conditions and automatically trigger a replacement. Yes, sir.
So in that sense, would the IoT sensor actually record something to the blockchain to indicate that hey, at this point, now there's an immutable record that this product has gone outside specifications?
That's exactly it. And some of the middleware that I was talking about earlier, typically because blockchain is immutable, right? You can't change it. You can't change what you write to it. It's probably not feasible to write time 0, this temperature, time 1, this temperature, time 2, this temperature. So by leveraging middleware to apply some business logic, you only have to record significant conditions. So this thing went above the exactly. This thing went above the temperature range for this amount of time. Record that event to the blockchain. Right? Yes, sir.
So one thing that's interesting here, though, is like from the moment it leaves the warehouse, I mean, it could be going to get customized. Not thinking technology. It could be going to get further customized per contractor, let's say, maybe like the IC or DoD or whatever.
Right.
It could very well could be going like on some random route to Fred's tackle shop. I don't know.
Yep.
But what I do know is that some agencies do not like things to be tracked.
Yep.
And the data, based off of the NIST thing last year, like the data of who, where, and what, those three things need to be obfuscated.
Right.
So what are some of the things you've seen as far as like the fact that some agencies don't like things tracked, and also that we don't want to look on the sticker and say, hey, this is going to this agency. You know?
Absolutely.
There's always like the mongoose effect of best intent is this, like kill the snake, but don't kill the 5 other things. You know?
Right. Yeah, that's a very good point. And so again, that's really where the middleware comes into play, right? And that's where you would implement business logic. For example, record this information, don't record this information, or anonymize this information. That's happening a lot in, I keep going back to the pharmaceutical case, but there's a pharmaceutical consortium that uses a blockchain distribution called Corda by the R3 group. And, pharmaceuticals are some of the most competitive companies on the planet, right? Because it costs so much to develop drugs. But they want to share information because it might help them discover drugs more quickly. So they have a very similar situation where they're recording patient data, clinical trial data, and that type of thing, and they want to share specific results, but they don't necessarily want to share patient names and things like that for regulatory compliance. So again, that really would be implemented more in the middleware as part of business logic to determine what gets recorded to the blockchain. Now, again, if a private organization or private enterprise is setting up a blockchain for its own uses, and it wants to have its upstream upstream suppliers, downstream distributors leverage that, there's got to be some level of agreement between them on how that's going to work. In a consortium, it may be a little bit more difficult because you've got direct competitors who are sharing this type of information as well. Make sense? Yes, ma'am. We have a slide.
Being hijacked basically to go from point A to point B, it's going from point A to point Z, but
right.
everybody thinks it's still going to B.
We have a slide on security for IoT later, but I think that's a very good point, and so we'll go ahead and address it now. In most tier one IoT providers, for example, not saying any company names, there needs to be some level of security at the endpoint, right? In a cellular environment, for example, there's the concept of access point names. You can think of a cellular access point name as a wireless LAN SSID or a VLAN tag, for example. The difference is in a cellular environment, the SIM chip that goes into, that connects the device has to be specifically provisioned with that access point name to even be able to connect to the network, right? So that's step one, making sure that only authorized things can even connect to the network. Step two is encrypting the data in transit. Most tier one providers do encrypt their mobility or their mobile cellular network traffic. Our company, for instance, encrypts it by default at 128-bit AES, but we can actually go up to 2048-bit AES if we're willing to pay the hit on battery life and time factor. There's encryption at rest, and so to a large extent, that's where your cloud service providers, or if you're putting this in an enterprise data center, whoever maintains and owns the servers that blockchain and applications are residing on, typically will implement some level of encryption as well. But there's also, in addition to those functional tactical steps, there also needs to be some level of monitoring and governance. These solutions have to be monitored effectively, and any deviation from the standards that have been implemented have to be addressed very, very quickly. But typically, it's a defense in-depth, multi-layered approach to addressing exactly the challenge that you mentioned. Any other questions on IoT security or how that might come into play? It's interesting, we're actually seeing a lot of work being done in the blockchain space using blockchain to create an immutable record of all of those transactions and things that happen that we just talked about. So blockchain, in addition to being a data store for the transactions, it can be a data store for the meta transactions to make sure that we're not being hacked or that we identify when something does happen. Okay? So some of the benefits of using blockchain we've talked about. It's a single source of truth, but that does mean that all the participants have to agree to use it. In the example that I mentioned of the consumer packaged goods company, they implemented the blockchain for their purposes, but they're one of the largest buyers of their upstream suppliers' materials. So they were able to exert a fair amount of pressure on that upstream supplier to also input data that was relevant into the blockchain. So they made sure that stuff, and there was a value for the supplier as well, they made sure that the stuff that was coming from the supplier actually was coming from the supplier. We're working with another company who they basically make glassware. They make bottles, but they make bottles for things like Crown Royal and higher end spirits and wines and things like that. One of the problems that they're having is people will, after the bottle has been used, they'll take the bottle and refill it with something substandard, screw the top back on, and resell it as the original article. So their problem, even though they're not the manufacturer of the spirit, since all of their customers are spirit manufacturers, they're very much willing to be involved and serialize the bottle so at least their link in the supply chain is not compromised. Now, yes, the spirit manufacturer, the wine vintner, has to do other things and work with the people that grow the grapes and the people that grow the wheat and things like that. But again, that's what they're doing to try to address the issue in their environment. Immutable records of batch numbers and other information that provides the provenance and the traceability, if you will, for the materials. Reduced time to respond, lower amount of stuff that you have to keep in the supply chain, less amount of time it takes to resolve issues when they happen. And in some cases, I mentioned the shipping into customs. The company in Atlanta that I was talking about, today, they ship their product all over the world. They have distributors in the United States. They have distributors overseas. In the United States, their point of sale, when they actually can get paid for their product, is when the distributor basically sends the material out to retailers. Today, that's a manual process. Somebody writes it down, they email that information back, and that's how they do their accounts receivable. And this is a Fortune 50 company, right? In the United States, by instrumenting the supply chain, they know exactly when it goes from the distributor down to the retailer. They can, using smart contracts, they can automatically track a point of sale. In the United States, that might mean they get paid a few days early, right? But think about their international shipments. Their point of sale internationally is when their shipment clears customs. Again, a very manual process. by automating that, instrumenting it with IoT sensors and other technologies. They can tell when that material moves from the customs house on. And I think they're forecasting in Latin America and the Asia Pacific region, they can get paid 30 to 45 days early. So tremendous positive accounts receivable impact. Yes, sir.
So with the smart contract, how many variables are able to be programmed into those smart contracts?
It's entirely up to the developer, up to the programmer. It could be one of the examples for the beverage or the consumer packaged goods company. Some of their retailers are very good corporate citizens. They only put their product in the branded coolers and things like that, and they want to incent them, right? So they're considering using micropayments they're using smart contracts for micropayments for that incentive. But they're also using it to ding the retailers that don't play very nicely and put competitors' products in the coolers as well. So by using an IoT sensor, an image sensor, basically a $10 cell phone camera, pointed right at the cooler, they're able to tell, are all the cans red or are any of the cans blue? And then that would trigger the micropayments or the micro debits, if you will. But that's a relatively simple smart contract. But they can be as complex or as simple as the developer needs them to be. No, and that would be to a large extent based on the specific blockchain platform that's in use. But in general, there's not a major hard limitation on that. Yes, sir.
The only problem I'm seeing is getting the training to all the people and getting people to actually do these things, right? You have to have it initiated somewhere where a person is standing there with these boxes and they're like, hey, don't forget to pack the sensor in there, right? Don't forget to activate that sensor. Take that one off the battery charger. There's got to be somewhere that there's a major breakdown of people, right?
There can be. And again, it depends.
You know what I mean?
I do. And it depends on the specific technology that's in use. To a large extent, most IoT implementations for most Tier 1 carriers have capabilities to address that. But honestly, that's one of the reasons that we're seeing a lot of organizations wanting to use cellular for connectivity, right? Because, well, you
set a geofence to say as soon as this leaves this building, it's
trigger it exactly.
It's cleared, right?
Exactly.
But it could be leaving that building to go to the landfill.
It could be. Yep.
So
You're absolutely right. But another characteristic, and we'll talk a little bit about different wireless technologies. You could do this with Wi-Fi, right? But Wi-Fi is very problematic for a number of reasons. Number one, it typically requires some level of custom configuration or customization, right? That has to be done based on the Wi-Fi conditions that are implemented. Number two, most Wi-Fi implementations, even in very large or corporate enterprises, are not really configured to a high standard of reliability or availability, right? That can be a challenge as well. With cellular and some other technologies like satellite, these devices can essentially come pre-activated or pre-configured, or to your point, they can be configured to activate once a certain condition is met, like it leaves a specific geofence location. That's a very good point. So this is an example of a basic supply chain scenario. And I won't read it to you, but essentially from the point that an order is placed, it goes through various stages, goes through distributor, and different things are triggered like payments. This is the way that it looks today. Well, the good news is it looks pretty much the same tomorrow. The only difference is we now have instrumentation, things like GPS location and geofencing, so we know when things move from a factory into a yard and into a distributor, for example. We may be using Bluetooth low energy tags in the pallet that allow us to know where things are as it moves within a building, right? And then we may have a cellular or satellite connection that shows where things are once they leave the building, when it's in transit, or when it's being shipped. Again, and we've got examples of these. Actually, I think it might be the next slide. I'll come back to that one. We've got examples of different devices that can be used at various sizes or locations. So, for example, Zergo, not an AT&T company, different company, and this is just an example, makes a container tracking device. Their container tracking device can go on a powered container, like a refrigerated container, and draw power from that unit. For unpowered containers, they actually have a couple of really innovative ways. One is and the one that's pictured here, uses a solar cell, right? So it can harvest energy from that. For ocean-going containers, they actually have a slug that moves along a ferrite core, so they can actually harvest the wave motion and generate a trickle charge to keep the battery updated. The one in the middle is a pallet from a company called RM2. There are a number of them. Pallet Alliance is another. But in general, most wooden pallets, number one, they're not very rugged, right? They may be used for 10 uses and then they're scrapped, right? So that represents a bit of a sustainability challenge in an area of waste. This company actually creates reusable pallets from recycled materials. So not only are they recycling the material, but these pallets are ruggedized and good for, I think they average them for about 100 uses. So reducing just the costs in pallets, but what they've actually done is install an LTE-M in this case, and I'll come back to that in just a minute, but they actually have a sensor in the pallet that has location, basic temperature, and shock conditions in the pallet. And so as part of the price that you would pay for the pallet, you actually get full connectivity and the ability to trace that pallet anywhere in the world. So not only is that good for putting packages on and knowing the condition of that, it's also good for recovering pallets, that get lost or stuck behind a store somewhere. And then the last thing is at the package level. This is from a company called Fleet Complete, but they basically have a very small sensor. And the battery life, I think what it says here, about 5 years, but it tracks not only location, but a lot of additional information as well. So at various levels, end to end throughout the supply chain, it's now cost effective and technologically effective to do so. One of the big things that has actually changed that are the emergence of what are called low power wide area or LPWA network. Now there are a number of different LPWA networks. One is LTE, or in this case LTE-M. So most people are familiar with LTE. That's the same technology that connects your cell phone, right? LTE is a very good solution, but it doesn't really work well for a number of reasons. Number one, it's very power hungry, right? Number two, there's not a very good, it relies on the device basically to manage the battery life. So how often do you have to recharge your cell phone? Think of that in an LTE environment. A new version of LTE was recently introduced, and most Tier 1 carriers have deployed to some extent LTE-M or LTE machine. LTE machine is specifically for IoT communications, whereas LTE has, I think the theoretical maximum is 400 megabits per second bandwidth. LTE-M tops out at about 384 kilobits, right? So it's not very good for streaming video, but if all you're sending is GPS location or temperature values, it works very, very well. Because it doesn't have to send as much data, and because it can actually turn the radio off when it's not in use, not only does it significantly improve the battery life, in some cases up to 8 to 10 years on a single charge, but it also has tremendously reduced the cost and the size of the cellular modules that need to be put on these sensors. I think the cost has come down about 80%. I mean, there are some LTE-M devices now that are in the sub $10 range. So it's very much more cost efficient and cost effective. Yes, sir.
Is that because it has fewer recharges available? Like is the lifespan of it overall reduced? Or?
No, so the battery life is increased. So let's say 2 AA batteries, right? Normally with an LTE device that may last a week, but LTE is typically an always-on technology. With LTE-M, where the built into the technology spec, it actually shuts the radio down, powers it on when it transmits, powers it down. So it's called sleep mode for LTE-M, but that's one of the big contributors to battery life. And again, it doesn't have to push multi-megabits, hundreds of megabits of data. It's 384 kilobits. So again, it's not the best technology for all applications, but specifically for machine-to-machine communications, it works very well. There are a number of others. And in addition, you've got NB-IoT, narrowband IoT. Though both of those, LTE and NB-IoT, are what's called licensed spectrum. So the GSM, the Global System for Multimedia Telecommunications, GSM organization, global regulatory body, administers, and defines what those are. There are some unlicensed spectrum options as well. So LoRa is one of them. Sigfox, you may be familiar with, and a few others. Sigfox is essentially a user-based consortium. LoRa is maintained and developed by the LoRa Alliance, but they utilize unlicensed spectrum, which is spectrum that is not assigned for use by, say, the FCC in the United States, for example. So, but there are different applications for each of those, and potentially any of those could be used in these types of environments. So just going back real quick, this is an example, before we move off of this, this is an example of the company that I mentioned that we worked with on their supply chain. They had 3 major points of problem where they lost visibility. Number one is right here when they received raw materials from their suppliers, right? They didn't know the condition of the raw materials. Sometimes they received stuff that had already spoiled, that was bad, and they had to discard it, but that also meant that they couldn't immediately then turn it into resellable products, so that caused some delay. They also had a challenge from their environment down to their distributors, and we talked about knowing when point of sale happens, right? So for them, it's not only about the amount of stuff they store in the supply chain, it's knowing when that stuff is used so they can take payment. And then the third area is what we talked about in terms of the retailer, knowing that you had good corporate citizens and bad corporate citizens, and being able to incent and demote each of those based on that information. But in their case, again, we worked with them to map out their supply chain and identify specific technology solutions to address some of those problems. In their case, Internet of Things, package, pallet, and cargo container, and blockchain. Again, in their case, they went with chose to use a specific cloud service provider for their solution. So just going a little bit more in detail in terms of location services, there are a number of different considerations for being able to instrument supply chains. One is the level of precision. How accurate do you need it to be? Some technologies like GPS, for instance, very, very good as long as you only need to know things within a range of a few meters. Within a warehouse or another facility, you may need to know where things are at a much greater level of precision, so that might dictate a different technology to be used, and we'll talk about a few of those in just a moment. Whether in-building coverage is required. If you're only tracking things outdoors, GPS may be a perfect option. If you need to track it indoors, you don't have line of sight to a satellite. So there are additional capabilities and technologies that you can bring to bear to address that. Battery life and usage time. Again, micro-location, high battery life, satellite location, typically low battery life. And again, to a large extent, that depends on the frequency and power bands and how often that information is being transmitted. Cost is also a key consideration as well. I mentioned that now with some of the emerging technologies, you can actually track assets in the sub $10 range. Again, the choice of technology, though, as you can see with satellite tracking, it depends on that. The cost depends on that technology as well as the cost of infrastructure. So, for instance, you can use, and we'll talk about radio frequency identification tags, RFID. The tags are now very, very cheap, right? You can get a tag that costs a few cents, but the readers can cost $10,000. So the cost of the infrastructure is one consideration. The cost of the tags themselves are another consideration. So just a few examples. When we talk about macro location, that's in the wide world, the most widely known is GPS. Doesn't work in building. Assisted GPS combines cellular tower or cell tower triangulation with GPS. So that essentially brings GPS level precision within a building. So you can get the same level of precision, but you can now do it indoors and outdoors. Pervasive asset management, though, that's really what we're seeing as kind of the emerging capability, and it's not just knowing that it is in this building, it's knowing which room is in this building. In a warehouse, it's knowing where it is in 3 dimensions, which bin and which shelf and that type of thing. Pervasive asset management with some of the technologies we mentioned, LTEM and others, now it makes much more sense and is a lot easier to implement in an indoor environment. Some of the examples, you can do this with Wi-Fi, right? Wi-Fi, typically there are multiple access points. It allows you to triangulate but there are some challenges with that. Number one, the Wi-Fi device tags are typically very large and bulky. They're typically very costly, and they're power hungry as well. So Wi-Fi may not be the best choice if longer battery life is what you're looking for. Bluetooth Low Energy and Zigbee, that's where we're seeing a tremendous amount of activity in this space. With Bluetooth Low Energy beacons or BLE beacons, there's the concept of reference points and access points and gateways. Right, so with a Bluetooth Low Energy tag, they're modestly priced, maybe $10 or $20, but you can tell with a high degree of precision where it is in 3 dimensions. Because you would put, for instance, a reference point on this wall, a reference point on that wall, and it uses the signal to triangulate where that component is in the building. With RFID, there are 2 flavors, active and passive. Passive RFID we're all familiar with. You ever gotten a jacket or something with a radio tag in it? That's passive RFID. Good thing, the good news is the tags are very, very cheap, and they actually have onboard storage. So you can actually store information. They store in a retail environment, you store UPC and price code, product code information. The bad news is it requires the tag needs to be interrogated by a reader, either a hand scanner or when it passes by, it comes in and goes out. So RFID is very good for knowing when things enter a building and when things leave a building. It's not very good for knowing where things are in a building. And again, the cost of the RFID reader infrastructure can be fairly high as well. Active RFID gives you much more range because it's actually a powered tag, and the tag broadcasts or transmits information instead of just waiting to be interrogated by a reader. But they are much more expensive. Active RFID tags, the readers are more expensive, and the tags are more expensive. But for high-value assets, like there's a defense contractor that has a manufacturing plant in Texas. They need to know where all of their tools are at all times, because not only is a foreign object debris risk, but these are tens of thousands of dollars worth of tools. So for them, it made sense to invest in active RFID so that they wouldn't have to know where it is to go up to interrogate it. The thing basically broadcasts its location, and you can also get additional information from active tags like speed and direction and things like that. But again, macro location or micro location, it's very important to match, to understand what the business or what the enterprise problem, the mission problem is, and then to select the appropriate technologies to successfully meet those requirements. Any questions so far on anything that we've covered? Okay. So the good news is we have a few minutes left. This is an example of a pervasive architecture, pervasive location architecture that we've actually implemented for enterprises. So in this case, we have the asset tag and the reference point. All of the reference points typically are aggregated back to a BLE access point. And in this case, their operation chose to use an LTE-M solution. Now, a lot of organizations are looking at cellular and others, but cellular and satellite as a secure out-of-band overlay network for collecting this information that doesn't require and doesn't interfere with existing Wi-Fi solutions, for example. So in a lot of cases, the organization may be using the same Wi-Fi infrastructure for end user communications as they are for supply chain and other asset type communications. Using cellular and other low power wide area technologies, again, doesn't require that and doesn't impact it. You got a question?
The Bluetooth Low Energy reference points, are the beacons also low energy? Like, what's the maintenance like on those?
They are, and they're typically field replaceable units. So basically, it would be a module. And there's different form factors, but a lot of Wi-Fi manufacturers, for instance, are now including BLE access points and even reference points in their Wi-Fi routers, for example.
I'm just thinking of the tile and those key locators.
Yep.
Are using this technology.
That's exactly it. And you bring up a very good point. Another reason that we're seeing BLE being used in these types of applications is it significantly reduces the cost of the infrastructure. Instead of a $10,000 RFID reader, you can use your cell phone. right? And so it makes it a lot easier to develop applications that use Bluetooth because you've got a Bluetooth radio and a device that most of us have in our pockets. If you're familiar with a lot of the airline onboard sales devices, in many cases those are just standard or potentially ruggedized cell phones, but they take advantage of those capabilities. So again, another consideration for using Bluetooth. We talked about security, multi-layer defense in depth. Regardless of the wireless technology that you use, it's imperative that you have effective endpoint access management, making sure that only authorized devices can even, in the case of cellular, see the network, but definitely access the network. Encryption in transit, encryption at rest, and then overall security monitoring and notification of any significant issues or concerns. And this is a little bit more detailed example of the consumer packaged goods company that we worked with. They really needed to track this material. Not only was the material itself high value, but it was also very perishable. So if it wasn't maintained within a specific temperature range, they would lose the entire shipment. The way that they did it previously was basically aggregate all of these barrels of material onto a pallet, onto a standard wooden pallet, load those onto a cargo container, and then put them on a ship or something like that. What we were able to do is work with them to, in their case, put Bluetooth low energy tags on each individual unit. So they were able to tell where in the building that product was. They were able to tell that this barrel of material was 2 weeks old, this barrel of material was 1 week old. Let's get rid of the 2-week-old barrel of material first because it had a shorter shelf life. Then they were able to aggregate all of those barrels onto a pallet, and in their case, they used the RM2 pallet. So not only were they able to know where it was in the building, they were also able to know where it was when it was in transit between their factory and their distributor location. By getting their distributor to participate in this as well, they were able to collect point of sale information. So when the material left their distributor, they were able to immediately basically debit that distributor for the cost of the material. In some cases, getting paid up to 30 to 45 days earlier. But the main issue and the main problem that we helped them solve was not having to store as much stuff in their supply chain, reducing stranded capital in the warehouse, and ultimately improving their bottom line profitability. Yes, sir.
I just think one thing is that when you think of food and agriculture, you always think about the waste and profitability, that kind of stuff. The reality is, though, if you talk about the audience this week, and as far as just the federal government, though, it is considered one of the 16 critical infrastructure, industries.
Absolutely.
So, you go from profits to two executive orders the past 2 years on supply chain security, and a lot of these different departments having to tie out with the CI to make sure that they have security in the supply chain.
Yep.
Because there's so much stuff that could be, jagged with. So this is actually good stuff as far as just securing the supply chain, let alone increasing profit.
Absolutely. Again, the number astounded me. So specifically as it relates to food, and I've been doing a lot of work in this space, 2 statistics. Number one, 40% of the food we produce globally is wasted. Right? Number 2, food fraud, not wastage, fraud, costs on average $40 billion a year. Talk about supply chain security and safety. Those are 2 areas of significant potential profit for malicious actors, and so I think that's where we're seeing a lot of that come from. But that's a very good point. Absolutely. So I think we're about ready to wrap up. If anyone has any questions or comments, please feel free. I'll be around for a bit after if you'd like to come up and share any information. And please don't forget to scan your badge on the way out.
Yeah, if any of you want to have further discussion with the gentleman, let me scan your badge and collect that information. I've never heard that.
Thank you. Thank you. Good questions.